Okay. Now, uh, as we have been going through this over the last few lectures, design patterns, we, inshallah, will be completing design patterns discussion today. So we know that there are three categories of design patterns: creational design patterns, and we have examples of singleton, factory, abstract factory, and so on and so forth. We have structural design patterns like facade, adapter, and bridge, and so on and so forth. And then we have behavioral design patterns. And the other day, we had a look at two of them. As was the case with other design categories, design patterns, there's so many of out there, but the ones which are very popular and heavily used, in this course, we selected them for discussion. So we had a look at the iterator design pattern the other day. Remember the iterator design pattern? It was iterating, help you iterate through in a sequential way, right? Uh,
Yes.
and and then we had a mediated design pattern, which was like, which acts as a mediator for all the communication happening between different objects, like the chat room example the other day. So today, inshallah, we'll be covering and completing this discussion on the design patterns by having a look at the design pattern called observer design pattern. And again, this is very commonly used, and this is something which is, gives you a very interesting behavioral property to your design. And I remember someone said that he has used observer design pattern, if I'm not mistaken. But yeah, let's look at the observer design pattern and, let's see what exactly it does. So observer design pattern is something where you have one to many relationship between objects in such a way that if one object is modified, its dependent objects are to be notified automatically. And that's the main idea behind this design pattern, that if one object is modified, its dependent objects are more notified or updated accordingly. And this is something which is very common scenario you face in your applications, and that's hence you use observer design pattern to handle such scenarios. Now, how it looks like, let's try to understand as we always do with the help of a simple example. So take a moment to have a look at this and see what's happening from a class diagram perspective. Let's see what you know what you believe is happening here. So what do you think, guys? What's happening here?
It's like that the subject have three or multi objects such as binary, octal, and hexa. And if one of them is updated, the state of it is in the subject, which will update because these three observers will be saved in the subject.
Correct. Correct. You kind of summarized it actually. So uh, this is probably like, a calculator example or something where you want to, given a state, a number, you want to, in this case, for example, you want to have its binary, octal, and hexa numbers displayed. But as we said in the previous slide, once you have a situation where you have one-to-many relationship between objects, such that if one object is modified, independent objects are notified automatically. So this is exactly what we're trying to do here, is that if the state changes, its equivalent representation should also change automatically. So we have, uh, something called subject here, an observer here, and of course, the client or the demo class. So In an observer design pattern, usually you have three, you will have three types of classes. First is your subject, then you will have observer, and then you will have client. So what subject does? Subject is an object having methods to attach and detach observers to a client object. So that's what the first role of the subject is. The role of the subject is to help you add or detach these observers you want to be automatically notified. And if you come back here, basically if you look, we are trying to attach. This is the first responsibility it does. You try to attach the observers you want to have in your system. And then of course you will have there is another thing which basically you do here in the subject, which is basically notify all observers, because you want to automatically notify them that certain things have changed, a certain state has changed. And of course, then you will have the observers themselves, and of course, these observers basically go on and give you, so basically you have an abstract class observer, and then you will have concrete class subjects, which will basically be implementing these observers. So in this case, your abstract class observer, and then your concretes are your binary observer, the octal observer, and the hexa observer. Now, let's look at this source code and see what exactly is happening in a subject. Take a moment. So see what we're doing here. We're creating a list, right? And it's a private one. Then we have a state here. Then we have something called get state, which is just to get your state. And then you have your set state. What's happening in a set state here now? Once you set a state, in addition to just setting the state, you also do one more thing. You call your notify all. Yeah, so you basically call notify all observers, and basically what happens in a notify all observer, basically you go through this your array list, right, and then you go on and update it, right? And of course you have one more thing here, which is your attach, which basically allows you to add a specific observer. Remember, a subject class in an observer design pattern is responsible for adding or detaching observers as well, right? So we basically add observers, which is in this case being maintained in an array list. And then of course you can get it, or you can set its state. And when the moment you set its state, you basically also notify all observers by basically traversing through your array list. Now, on the other hand, we have our abstract observer class, and basically, it has this abstract update method, and each one of the concrete class will give its own implementation for this update method. So basically, you have your binary observers. This is the constructor of this one. Basically, what's happening inside the constructor here?
You are creating a new subject and attach it.
Exactly. So basically, whatever the object will be passed here, that will be attached. So you'll be attaching this one. Exactly. So you'll be attaching it. And what was happening in the attachment? You were basically adding them to your array list, right?
Yes.
And then you have an update one. And in the update one, in this case, basically, because it's a binary observer, so you're basically doing simple integer to binary string, right? And the same thing will happen in your octal. Again, you will add that specific subject into your your to your attach that specific observer to your list. And of course here you'll do an integer to octal string, and similarly on the hexa side you will do the same thing, and basically in the update override method basically will go on and do integer to hexa string. So once you have done this, let's see what's happening here on the client side. So first of all, you go on and create a subject, right? So you create an object subject. Then,
Doctor, I have a question, please.
Yes, go ahead, please.
The array list was inside the subject class?
The array list was inside the subject class, yes.
Mm.
So if you come back here, array list was in the subject class.
Good to
All right.
okay.
So once we come here, we create an object. Now what will happen here? We're creating a new observer here now, right? So we are, for example, any one of them, by the way. So we are creating a new observer here, hexa observer in this case. And remember what was happening here? When the moment you try to create a new observer, what will happen? So you basically send the subject and you basically attach it. And in the attachment, basically you're doing what? You're adding that to the list, right? So basically you go on and create these three ones. Now, what will be the output of this? How many we don't know the outputs, to be honest. Like, I don't expect you to know it, the representation. But what will be, how many outputs will be generated after this statement?
3.
3.
Because we have 3 observers.
Exactly. And remember what was happening in the set state? In the set state, what was happening in the set state? So we set a number 15 here.
Yeah.
So, so, and then we also notify all observers. So basically when we notify that 15, it will go on and go through the list of observers we have in our linked list, or in this list of in an array list, and basically it will call the observe.update method for that specific observer. So it will be called for hexa, it will be called for octal, it will be called for binary. And so will happen with this one as well, right? So in a nutshell, you will have something like this. Now, if you come back to the statement we studied in the beginning of the observer design pattern, this is exactly what the idea was. Observer is a pattern in which there is one-to-many relationship between objects such that if one object is modified, its dependent objects are notified automatically. And that's exactly what is happening here. That you change the state of an object here, automatically, in this case, we had 3 observers and they were, they were all notified, and hence you get an updated value for that. Is this design pattern clear to everyone?
Yes, Doctor.
Great. It's something which is very commonly used, and something which is, I'm very sure and I'm very confident that you will, come across scenarios where probably you will like to use such a situation. And basically, what's the biggest advantage you guys see by having such an automated update? What's the biggest advantage from a client side perspective?
Maybe I don't want to update all of them. I want to update specific things, maybe.
But this is for updating all of them in one go, right? So what's the biggest advantage from a client side? Please.
Making the client not know about the, how the notification works. The client just sets the state, and whatever observers are attached to that subject will be notified. If
Exactly.
later an observer added, yes, he can also do the same thing.
Exactly. This is the biggest strength, right? This is the biggest strength that, he doesn't need to know, or this demo class doesn't need to know everything. It all needs to know is that I have a subject, I'll call it, and that's it. I'll set the state and I'll get the right behavior, or I'll get or everything is done automatically. So this is what the whole idea behind this is, that, if you have one-to-many relationship between objects, such that if one object is modified and you want automatically to notify all the other dependent objects, the design pattern you should come to your mind is observer design pattern. So with this, alhamdulillah, we come to a state where we have finished, the design patterns we need to know in 316. There are quite a few others, by the way, out there. You can explore them on your own through the web, of course, through the Gang of Four famous book. Plus, hopefully, inshallah ta'ala, if you guys get an opportunity and you're interested, our elective course 436, actually the whole course is on design patterns. So they basically go into a lot of more design patterns and more complicated design patterns as well. And that whole specific course is all about design patterns. So any questions on which we, the design patterns we have covered, or we're quite good?
Doctor,
Yes, please.
this
Yes,
is
please.
just a book to us to read about the design pattern.
Okay. A Gang of Four is a very famous book, right? And I think it's called a Gang of Four. So it's a terminology we use. It's called. Let me just Google it for you guys. Yeah. So the title of the book is basically Elements of Reusable Object-Oriented Software. No, sorry, not this one. Sorry, this one. Design patterns. Yeah, the title is Design Patterns, Elements of Reusable Object-Oriented Software, and it's called Gang of Four because it was written by 4 authors, and they were the first ones way back, which actually kind of cataloged these design patterns. So I know when 436 is taught by Dr. Khalid Al-Jasir, he usually follows that book, because that book is on design patterns itself. So the whole book is on design patterns. Yeah. Yes, please.
How can we know? How can objects like same as binary observer and hex observer give notify other objects that are connected with the observer, the main one?
How they are being notified?
Yes.
Okay. So see what happened here. Let's start from the other side now. So basically, we said that the value is 15, right? So we set the state to 15. And now the moment we set the state to 15, the client, if I go back here, where is the client? Yeah, so the client actually, will call the subject itself, right? So it was calling the subject. So basically you created an object of subject and then you set its state to 15, correct? Now, when you send its state to 15, it will come here. So the state is 15. It will say that this state is 15, and then there's a method called notify all observers. And what happens in a notify all observers within this set state, that this method, now the control will move to this method, notify all observers, which basically is doing nothing but going through the list, array list of observers, and calling for each observer its update, specific update. So when it will be calling each observer's specific update, like in our case, we have a binary observer update will be called, and it will just do print on, print to binary string. Or similarly, hexas will update will be called and will do integer to octal string, and hexa and octal and so on and so forth, right? So basically, if you look, you only set the state to 15. Automatically, you know, as part of your set state method, you notified all. And when you notified all, basically in the notify all, you actually traverse through all of these ones one by one and call its specific update method. And once you did this, you know, you get these three inputs, three outputs. Is this clear?
Yes, doctor. Thank you.
Great, great. Okay, so alhamdulillah, we come to conclusion of the design patterns. Now, what I will do now is basically, you know, before we move on to the last couple of topics we're supposed to cover in this semester, I'll give you a short, lecture which basically kind of gives you more like a discussion, an overview of, or not, I shouldn't be saying overview, more like a discussion of the summary of what we have, you know, learned throughout the semester. Just, you know, more like a discussion and, you know, some kind of a principles or some kind of rule of thumbs, okay? And hopefully this will give you, you know, like a more like a pointers in a sense that, you know, when I'm designing systems, I should be considering these things. And now I'm very confident, you know, the techniques, you know, the rules, you know, abstraction, encapsulation, inheritance, polymorphism, I taught you in the beginning of the semester, you know, architectural styles, you know, package principles, you know, solid principles, you know, design patterns as well now, right? So, you know, let's do that. Let's have a more like a, it's almost more like rule of thumbs, right? And we just, you know, gonna go through these rules just to put things in perspective for you, that, you know, when you're designing applications, if you consider these rules with and then it will hopefully give you a good design as well. Of course, you still know the techniques, so you basically go on and apply those techniques, right? Okay. No, again, I think they have a bug here, so I might have to share the whole screen here. Are you able to see the screen?
Yes, we can.
Great, thank you very much. Okay, so I think after 1.5 hours of talking, I think the pain is catching up to me now. So basically, you know, these are the some practical tips, some basically rule of thumb, some principles, which basically helps us connect the dots of all the techniques we have learned. This is more like, you know, a very high level, you know, practical tips. So we will be looking at them, then, you know, if you use these practical tips where and if appropriate, you will tend to have a good design. Of course, the techniques under the hood are still the same. You know, you will have to achieve certain of these principles, you will be either applying solid principles, or you either will be applying package principles, or you will be using design patterns, or you will be using the abstraction, encapsulation, inheritance, and polymorphism principles. So basically, there are 11 of them, and we'll see how much we can cover. So, you know, they gives you very, very, you know, abstractly, that, you know, if you follow and try your best to follow these principles, rule of thumbs, you tend to have good design. So let's look at them one by one. The number one, of course, before even this, we need to know that why we are interested in good design. We are interested in good design because at the end of the day, the goal of a good design is what? First of all, we are very much, we want to ensure that, we actually come up with a design of a system which follows or fulfills the requirement. In other words, it's incorrect to have a design which is not satisfying the requirements. No matter you made your design modular, no matter you used very fancy architecture styles, or you use solid principles, or you use design patterns, it is incorrect. It's meaningless, because if we somehow did not follow the requirements. So a good design by definition is a good design if it follows the requirement, if it satisfies the requirement, then the other things comes up, and as a result, if you have a good design, it follows the requirements, it's better structured, it follows the principles we're going to show very shortly. As a result, probably you will have a faster development time. Hopefully it will give you less cost, and it will also help you, some of the quality properties you're trying to achieve, some non-functional properties you're trying to achieve in your system, such as, maintainability, or you want to reuse your systems, or maybe if your given system wants to have reliability or usability functionalities or features, quality attributes, these designs will help you achieve those principles. So in a nutshell, these principles, once you apply them and you use them, they will lead you to making sure that your requirements are fulfilled in your design. You make a system in such a way, or you design such a system in such a way that it's faster for you to implement, or it will save some cost for sure. And it's easy to read, it's easy to maintain, it's easy to reuse, easy to achieve certain quality attributes you're trying to achieve in your system. So the very first principle, the rule of thumb, is divide and conquer. By the way, all of these design principles are non-technical in a sense. I mean, it doesn't have any lot of technicalities here, because, as I said, it's a summary of what we have learned. So, you know the technicalities now. So first rule says what? Divide and conquer. So basically go on. Don't try to deal with something very big in one go. It's very hard, complex systems. You cannot really comprehend each and every part of it in one go. If you want to design, don't try to design the whole system in one go. Try to do what? Try to divide and conquer. Because if you're going to try to deal with something very big in one go, normally it will be harder and it will be challenging. So, if you divide your system into smaller units, subsystems, packages, components, then separate team members can work on each of these parts. Each individual component will be smaller, each subsystem will be smaller, therefore it will be easy for you to understand. And basically, if you can understand, you can design them better. And of course, it will be easy for you that if you're looking for reusability, if you're looking for replacing them to changing them, you may be able to replace or change them without really needing to do a lot of changing in other parts. So this is the whole idea of divide and conquer. Don't try to do everything in one go. And here, if you recall, your principles, architectural design principles you learned, remember in architectural design, architectural styles, what you were doing? You were coming up with components. You were coming up with subsystems, correct? And
Yes.
Yes, and then and when you were doing that, basically you were trying to, for example, have clients or servers, or you want to have event bus and individual components, individual programs, so on and so forth. So you're trying to basically divide and conquer your system. So as we already know these ones, by the way, now different ways you can divide your subsystems, of course, is first of all, architecture plays a very big role here. So whatever the architectural style you will select for your your system, that specific design decision, the principal design decision you will take at an architecture level, of course, will help you achieve this rule number one, which is divide and conquer. Because as a result, for example, if you're using a client server architecture, then you will have clients and servers. It's already the whole system is already divided into subsystems, right? Of course, then you can, based on your architecture styles, you can divide your systems into subsystems. You can even divide your subsystems into packages, and now packages as well, right? And of course, these packages eventually can be further, they will be further divided at a class level, and each class eventually will consist of many methods. So this is what is happening. You are actually, from architecture level all the way to the detailed design level. If you try to divide your system into smaller units, it will give you better design. Everybody's comfortable with this?
Yes.
All right. So again, this is generally the general observation of all the stuff we have technically learned over the last 12 weeks. We already know this now. We have seen this again and again. We saw this in the packages. We saw this in design patterns and in solid principles. That it's as a good designer, you always try to increase cohesion where possible. So we understand that, you cannot have like 100% cohesion in a sense, because it will start deteriorating some other aspects of the design, but you try to increase cohesion where possible. So a subsystem or a module is called high cohesive if it keeps together things that are related to each other and keeps out other things, right? So basically, what you really do is you try to come up with high cohesion, and the way you can do it is each unit, each thing you subdivide it as part of the rule number one, subsystems, packages, or classes, or components. You will say I will have high cohesion. You try your best to keep all the things together which are related to each other. So of course, once you have high cohesion, it makes your system a lot easier to understand and change. We all understand this now, I believe so. Now, on the other hand, you also try, so rule number third now is that, principle number 3 is that you reduce coupling where possible. So basically, you also try to reduce your coupling, overall coupling of your system. So increase cohesion, try to reduce coupling. And of course, coupling occurs when you have interdependencies between one module and another, right? So of course you cannot avoid coupling. It probably will not happen. Otherwise you will again, have some other issues in your design. But you try to minimize coupling where possible. So when there are interdependencies exist, of course, changing in one place will require changes in other as well. And you are always interested in trying to minimize these, changes. And of course, if you have a very high network of interdependencies between components and subsystems, it will be harder for you to understand it. It will be harder for you to comprehend it, and of course, eventually implement it. Something like this, right? That if you have a lot of interdependencies or coupling happening, probably this is more cleaner, more easier to maintain, right? Now, do you recall any architectural style which was helping us reduce coupling or was promoting loose coupling?
The publisher subscriber?
Correct, absolutely. Absolutely. Any other comes to mind?
Filter and pipes.
Pipes and filters. Well, from a coupling perspective, inherently it doesn't really worry about coupling. In addition to publisher subscriber, anything comes to mind? What about P2P?
So maybe Blackboard, not Blackboard, sorry, event based.
Event based, yes. Because
Because
each
it's subsystems. our dimensional system. So
Exactly. What about P2P?
P2P,
Also
I don't
P2P.
think it's.
Remember what was happening in a P2P cup? The Mozilla or one of those. Sorry, not Mozilla. The Napster and the Gontaila. Peers can join, peers can leave, right? Highly
Yes.
scalable, right? So see, that was from an architectural perspective. Do you recall any design pattern which helps you reduce coupling?
Maybe facade.
Absolutely.
And mediator too. I think it's reduced coupling.
Exactly. See how these all things which we have learned now are all gelling together. So basically, you're gonna look at these design principles and then say, okay, I need to achieve this. So basically, so far it tells you what design rule number one was what, rule of thumb number one was what, divide and conquer. Again, you say, oh, I need to use architectural concepts. I need to come up with packages. I need to come up with classes. I should have methods in it. This is what I would try to do. This is something you guys do anyway, but this is, will lead to a good design. Increase cohesion, right? Again, for cohesiveness, you learned a couple of principles in the package level, right? So you basically go on and try to increase the cohesion there. Remove cycles and all of that kind of stuff, right? And also reduce coupling by removing the cycles, looking at the dependencies, looking at certain design patterns, which helps you decouple your systems. Even architectural styles, which helps you reduce coupling. So I think everybody's comfortable with this now, right?
Yes.
Number 4 principle is keep the level of abstractions as high as possible. Again, I think you guys have learned this as well. So basically, you ensure that all the designs allow you to hide or differ consideration and details, thus reducing the complexity. So in other words, you want to only expose part of a subsystem or a component or a package which is absolutely necessary. The inner workings, you try to hide them with the help of these abstractions. So basically, abstractions allow you to understand the essence of a subsystem without you having to know unnecessary details. You don't want everybody to so you try to make your subsystems more as a black box, and you say these are the interfaces, these are the functionalities it will provide. Give me these parameters, and I'll take care of it for you. So basically, as I said, you achieve this design principle or 4, which keeping the level of abstraction as high as possible by help of your abstractions and classes. So basically, classes inherently give you this abstraction, because when you create attributes, they give you data abstractions, and then when you create more method, it gives you procedural abstractions. As a rule of thumb, it's always advisable, and we know this, that in a class, we always try to have fewer public methods. We also try to use interfaces as much as possible, right, to increase abstractions. I'm pretty sure in the design patterns, you saw a lot of application of interfaces, right?
Yes, sure.
Yeah, right. So basically, we try to again follow this rule number 4, which is have high abstraction, as much as high abstraction as possible, by using these interfaces, using the design patterns you have learned. Make fewer of these public methods in a class. Use attributes and associations for your data abstractions. Use your method for a procedural abstraction. And better abstractions are achieved by giving fewer method parameters as well. What's the meaning of this one? That, give methods fewer parameters.
This helps with splitting. So give each method has one responsibility.
Exactly. I'm over the moon now, mashallah. I'm very happy you guys are picking up all of this stuff. So yes, exactly. In other words, if you give so many parameters, this means probably this method is doing so many things, which is again counterproductive, right? So how many principles we know now? divide and conquer, increase cohesion, reduce coupling, try to have as high abstraction as possible, right?
Yes.
Now this leads us to the fifth and the sixth one, which are interrelated in a sense that, you try your best to increase reusability where possible again, right? So design various aspects of your system so that they can be reused again in other contexts within the same system or within the same company or across companies. Especially if you're developing software product lines, you're working for a company which is basically, developing a range of projects, and like Samsung or Apple, and basically, they have so many common functionalities among their products, and then they have variations between them. So, you don't want to write each and every time the same part again and again. You want to somehow design your system in such a way, your packages, your subsystems, your components, your even classes in such a way that you enhance reusability opportunity as much as possible. So basically how you do it, basically the more the general your design will be, the more the better it will be, right, for you from a reusability perspective. You keep your designs as simple as possible. This means, you don't have unnecessary constraints on it. And because the minimal the number of constraints, the easier it will be for you to reuse. And this leads us to the sixth one, which is basically, you try to reuse existing design as much as possible. Number 5 was saying design your system in such a way that, it's possible for you to reuse it in some other parts. Number 6 is just an opposite of it, which says basically when you're designing systems, you try to don't reinvent the wheel every time. If there are existing designs, if there are existing code in your company, or you can purchase it off the shelf, you have plugins, just use it. So, it basically complements your rule number 5, which was designed for reusability. Actively reusing design or code allows you to take advantage of the investment you have done, or maybe others have done, in these reusable components. Now, what I mean by investment here, what comes to mind, what I'm trying to say, that, if you're going to reuse someone else's code or design, you will be taking advantage of the investment they have done. What kind of investment? Or what's the advantage you will get? Any thoughts?
Maybe the other's code is better than my code in this specific area, so I should just take it and see how they do it and use it, or maybe just develop it too.
Fair enough, fair enough. Anything else comes to mind?
Doctor,
Yes, go ahead, please.
I think making components takes a lot of time and effort. So this investment of time and effort will be helpful in the future whenever a change occurs.
Yes.
So if a change occurs, it will be, less of a rippling effect.
True. And Yahya says time investment. Yes, they have spent time there, and probably the biggest advantage, by the way, you will get is that because someone else has designed it and coded it, and probably they are using it. This means they must have done a lot of testing of that part, right? So basically, the bugs probably have been fixed. They have invested a lot of time in stabilizing that piece of design or code. So you will take an advantage of this. And in addition to what you guys said, in addition to probably you will have a bit of a time saving as well, right? As Yahya said, right? Because the code has been written already, as long as you're able to plug in. Now, do you remember or do you recall any design pattern in which we thought about reusing code and it was helpful there? Remember the adapter? The media player example? Right?
When we used the adapter button, right?
Yes, yes, the adapter button where we have the MP3 player file and VLC players and so on and so forth, right?
Yes, yes. But I think there is an issue with it.
Uh-huh.
Maybe I have this component, but maybe this component have things that I won't use it. So it's
Ah,
just
yes.
useless for me.
Yeah, yes. That's true, so that's true. And it's always a big dilemma with the reuse, definitely. And that's why, usually it looks very fancy on a piece of paper that I should be reusing as much as I can. But in practicality, you have to be careful with these reuse. Usually, that's why typically they make a lot of sense in this SPL environment, the software product line environment, because the company themselves are preparing these components. So they are aware of what kind of functionality they're looking for and so on and so forth. Or if they have been designed in such a way that they're so generic like Google Map that it just plugs in. Right? So how much time we have, guys? Maybe 1 minute, right?
Yes, 1 minute.
Okay, so probably we'll stop it here, inshallah, and we'll look at this flexibility and others, inshallah, on Thursday, inshallah ta'ala. Right? So let me stop the recording and take attendance.